Welcome to these classes about design patterns. Today I will explain how the builder pattern works to you. First I will explain the theoretical side of the pattern. After that we will implement the builder pattern step by step by using C#. Let's start with the intention. The pattern distinguishes the construction of a complex object from its representation, allowing the same construction process to generate different representations. If you don't get it yet, that's fine. You will throughout this lesson. The participants. What entities interact with each other and what interactions do they have? First up is the builder. The builder is an abstract entity that specifies functions for creating parts of a product object. Then you have the concrete builder, which implements a builder, the abstract builder, tracks the representation of the product and provides an interface for retrieving the product. The director. The director directs the construction of the product by using the builder interface. And as last, what is being built is the product. And this is the complex product which gets constructed by the concrete builder. Consequences. Implementing a design pattern has consequences for the system you are building. Now we are going to look at what the consequences are for implementing the builder pattern. It lets you vary a product's internal representations. The director uses the interface of the builder to create different types of a product. For example, a simple or a complex product. You could have a phone without internet, Bluetooth, cameras and such, a simple product, or one with those features, which would be a complex product. The concrete implementation of building a part are hidden in the concrete builder. So to create a product with a different internal representation, you can create a new concrete builder. So each new builder makes a different product, but how the product is configured can differ. The pattern isolates code for construction and representation. The concrete builder encapsulates the parts which make up the product. For the clients, these parts are hidden. With these parts, the director can create variants of the product. So meaning the building recipe is hidden for the client. It gives you finer control over the construction process. The product is built under the control of the director, meaning you can build it part after part and leave out parts that you don't need. Now we are going to look at the diagram. So what does the builder pattern look like in UML, Unified Modeling Language? The concrete builder inherits the abstract builder interface or abstract class. And the director class has an abstract builder. And the concrete builder has a product. This is basically what the design looks like. Let's go to the assignment. Now we are going to actually implement the pattern in C#. The assignment will be given step by step. Try to complete a step by yourself first. After each step I will show you the code so you can verify your work. The first task. First we will create a product that will be constructed step by the builder. The requirements. Requirement 1. Define a class that represents a complex object to be built. This class should have several properties, representing different parts of the object. Requirement 2. Include methods to display the constructed object and its components. Let's get started. I created a console application and I am using .NET 8. I assume you know how to create a console application. Now I'm going to show you how to create the product class. So it's a class. Let's make it public. And we're going to keep it simple. I will give the product the properties CPU, RAM, motherboard, power supply, case, display, webcam, and keyboard. So it's going to be a PC configurator, I guess. That's a problem. Let's make it PC case then. And I forgot they are properties, so they should have capital letters. Let's change that real quick. Okay, these are the properties of the product. Now remember the theory remember the theory. We want to be able to create different types of the same product. That's why we made the properties nullable. There's two different ways of looking at this. You could say the CPU, RAM, motherboard, and power supply are core features, so these properties shouldn't be nullable. One could also say they can all be nullable, and a hypothetical client could buy a CPU with the motherboard and leave the rest out. This kind of decision depends on the business case. I chose to make them all nullable. We want to be able to display the product properties, so let's create a display function. The function will be a void and has null checks, since some of the product properties may be null. If it isn't null, we are going to write to the console. And let's just write the CPU. And we are going to do the same for all the properties. Okay, whatever. PC case. And let's change this. I don't like it. Okay. It already. Okay, we of course made a. Let's turn this into screen instead of display. And we also didn't. Okay, power supply. If screen. Yeah. Okay. Like this. So this is the display function. Now let's move on to the next task. Task 2. Define the builder interface. Create an interface for building the product. The requirements are: define an interface that declares methods for building different parts of the product. Requirement 2, include methods to initialize or reset the product. And requirement 3, the interface should define separate methods for each part of the product. Now let's keep moving and create the abstract builder. I will be using an interface, but you could also use an abstract class. The builder interface is the contract for the concrete builder, and it will have empty functions. Let's create the interface. I'll just do class, and then interface, and let's call it iBuilder. This is the abstract builder. On to the next assignment. Task 3. Implement concrete builders. Create concrete builder classes that implement the builder interface. The first requirement is: implement one or more concrete builder classes that provide specific implementations of each method in the builder interface. Requirement 2. Each builder class should be responsible for building parts of the product and storing the resulting product instance. Now we are going to implement the abstract builder into the concrete builder. This is where the properties of the product are initialized. This is the concrete builder. Let's move on to the director. The fourth task, implement the director class. Create a director class that controls the construction process. So requirement 1, implement a director class that uses a builder to create a product. Requirement 2, the director should have methods to construct different variations of the product using the builder. For example, a simple product or a complex product. And requirement 3, the director does not need to know the details of the construction, but should delegate the process to the builder. The concrete builder encapsulates the process, remember? The director manages or directs the building process. I will give two functions. One function creates a simple product, a basic PC. The second one creates a complex product, a PC with a webcam, keyboard and display. Now you see why we created the builder interface. The director accepts any builder of type iBuilder. This way you can use different builders with the same director. Now let's move to the task where everything comes together. And the last task is test the builder pattern. Write test code to construct the product using different builder configurations. The first requirement. In the main method of the console application, create instances of the director and concrete builders. Requirement 2. Use the director to construct the product by calling different configurations and displaying the final result. The last requirement. Ensure that the product can be built with different variations and parts using the builder. Now we are going to test the builder pattern. First I'm going to create a simple product and display it to the console. And here we see the basic PC. Up next is the complex product. The process is pretty much the same. The difference is one function from the director. And here we see the complex product, the PC with the extra stuff. You should have a basic understanding of the builder pattern now. If that's not the case, rewatch parts of the video you don't understand properly or play around with the code. In any case, keep watching for the bonus assignment. An optional bonus assignment is making a fluent builder interface. Enhance the builder with a fluent interface. So requirement 1, refactor the builder classes to allow method chaining, so that the construction of the product can be done more fluently. Second requirement, modify the builder methods to return the builder instance, allowing calls to be chained together in a single line. By creating a fluent builder, we can chain the building functions inside the director. First, we need to create a new builder interface, because each function is going to return the builder itself. Next, we are going to create a new concrete builder which implements the fluent builder interface. Now we have to complement the director with the fluent way of building the product. At last we are going to test the fluent way. We forgot to build a constructor. Let me do that real quick. So now it should work. And here we see the first PC configuration from the regular concrete builder, and secondly from the fluent builder. As you see, it's the same result. But what it's the difference is the method chaining here. Personally, I like the fluent way of building the product, but the first way is not wrong. I hope you have a good understanding of the builder pattern now. This was my presentation about the builder design pattern. Here are my socials if you want to know more about me, and I hope you learned a lot about the builder design pattern.